Okay, welcome back to learning about matrices for methods 1 and 2. Okay, this video we're going to be looking at matrix multiplication. Whoops. Whoa, what have I done? Matrix multiplication. Let me just get that heading back. There we go. Okay, matrix multiplication. Now, here I've defined three different matrices. Notice matrix A and matrix B are both the same size or the same order. They're both 2 by 3 matrices. They've got 2 rows going down, this row and the bottom row, and they've got 3 columns. So they've got this column, and this column. So they're 2 by 3 matrices. Matrix C, however, is a 3 by 2 matrix. It's got 3 rows and 2 columns. What I'm going to try is just multiplying these together. So just keep in the back of your minds, A and B, they're the same size, they're 2 by 3. C is 3 by 2. Okay, so with addition and subtraction, just to refresh our memories, if we try and add A and B, it will work because they're the same size. But if we add A and C, it won't work because they're different sizes. Let's try that. So A and B, A plus B should work. Yep, there we go, worked. Now let's try A plus C. Whoa, dimension mismatch. The dimension, or the order, is different. So, or is different, so it's not allowed for addition. So we can't have that one. Now let's try for multiplication. So let's do A plus B. So we're multiplying the two that are the same dimension, the same order. Oh, and it says there's a dimension error. Okay, so it's not allowed, in this case, just because they're the same size isn't good enough to multiply them together. Let's try A times C. That's interesting. A times C is allowed, and it created this smaller matrix that's a 2 by 2. Even though, if we go back, A is 2 by 3, and C is 3 by 2. Very interesting. Now let's see what happens if we do matrix C times matrix A. Wow, that's interesting. So here, A times C and C times A, they're completely different. They're even a different size. Okay, so let's write some notes down for this. Okay, so firstly, matrix multiplication is not commutative, or associative. So in other words, order does matter. Okay, that's the first thing to know. Order does matter, and saying that A times B is not necessarily the same as B times A. Okay. Well, yeah, you can't assume this. You cannot assume that they will be the same. Alright, we also have that when we did our matrix that was a 2 by 3 matrix, and we multiplied it by a 3 by 2 matrix, it did work. This was the case that did work, and we got out, and the answer was a 2 by 2 matrix. Now, also, when we did these in the other order, when we did the 3 by 2 matrix times the 2 by 3 matrix, our answer was a 3 by 3 matrix. So let's just have a look at that to remind ourselves that that's what happened. So here, A times C was the 3 by 2. So there's the 2 by 3 is A times 3 by 2. Gave us this one, and then when we did them in another order, we got a 3 by 3 matrix back. Okay, so in general, whereas let's do one more. When we had the 2 by 3 matrix, and we tried to times it by another 2 by 3 matrix, that it was not allowed. Okay, so a couple of things going on here that we need to be aware of. So let's do a general case. If we do a matrix that's m by n, and we multiply it by one that's mn, I guess let's just do O by P. So that's an O. Okay. So when we do an m by n matrix by an O by P matrix, so the word matrix should really be in here somewhere, so we don't get confused, but you know what I mean. This n and this O, they must be the same if it's to work. Okay, so you see here, the 3 is the same as the 3, so the two things next closest to each other. So the columns of the first one must match the rows, number of rows, of the second one. Same here, the 2 and the 2. Whereas in this case it didn't work, the 3 and the 2 are different to each other. So these bits together are what we call the inner product. And they must be equal. Okay, so those must be equal. So because they're equal, we could have written this O instead of the O. We can just write another n there instead. So let's write n there to show that this n and that n, they must be the same in order for the matrix to be multiplying apart. Now the other bit, we've got the m and the p. They are what's known as the outer product. And the outer product actually, they determine the size slash order slash dimension of the answer of the result. Okay, so the outer product actually determines the size of the answer. So if you notice on this one, we've got a 2 and a 2 on the outside, so our answer is a 2 by 2. This one, we've got a 3 and a 3, so our answer is a 3 by 3 matrix. Now let's do one more example on the calculator to investigate this outer product a little bit more. Okay, so here we've defined two more matrices. Got matrix D, which is a 4 by 2, matrix E, which is a 2 by 3. So 4 by 2, 2 by 3. Let's write that down. So we've got a 4 by 2 and a 2 by 3. So matrix times 2 by 3 matrix. Okay, so we notice that the inner product, the 2 and the 2, they are the same, so we are going to get an answer. Let's see what answer it is that we get. So let's do our matrix D times matrix E. And there we go. Our answer, we have a 4 by 3 matrix as our answer. Okay, so we have a 4 by 3 matrix answer. So we notice that this 4 is there and this 3 is there. So our outer product, our resultant matrix has an order. So the resultant matrix order is M by P. So M by P is our resultant dimensions of our final matrix when we do multiplication. Okay, so that gives us the dimensions and whether or not we are able to multiply matrices. Now what we want to do is actually be able to find the answer when we do multiply matrices. Now, so let's suppose we've got two matrices. We've got, let's define them, matrix A and matrix B. So let me just write these out for you. Alright, so we've got matrix A and matrix B, and what we're going to be wanting to do is we're going to be wanting to multiply these together. We want to do A times B. Now let's just look at to see if this is actually possible. Our matrix A has order 2 by 3, so it's a 2 by 3 matrix, and we're wanting to multiply that by matrix B, which is a 2 by 4 matrix, 2 by 4 matrix, and the inner product is actually not the same, so this is not allowed. Okay, so that example is actually not allowed. So to change it to allowed, we have to actually change our matrix so that it is actually allowed. So we know that the inner product needs to be the same. So if I change this matrix so that it's instead of a 2 by 3 and make it a 3 by 2, it will be allowed. Okay, so let's change this matrix so that it's allowed. 3 and 1 will do. Okay, so I've just changed this matrix. The order of it is now 3 by 2. Okay, it's now a 3 by 2 matrix. So now it is allowed because the inner product is the same. Is allowed because the inner product, the 2 and the 2, is the same, and the resultant matrix dimensions, the resultant dimensions will be a 3 by 4 matrix. So we're going to have a 3 by 4 matrix when we do our matrix A times matrix B. Okay, now let me just tell you that the key thing when we're doing matrix multiplication is we always do, so we notice that A is first and B is second, we always do the rows of matrix A multiplied by the columns of matrix B. Okay, the rows of A, so going across of A, are going to be multiplied by the columns of B going down. And you'll see that this is why the inner products must be the same as each other. Because the row of A is, there's 2 things in the row of A, and there are 2 things in the column of B. So it actually makes sense to be multiplying those things together. So let's set this up. Our A times B. I'll just write these together because this is how you'll be setting them out. So I think it'll be good to give you an example of this. So there's our matrix A and our matrix B. Okay, so, and this is going to give us a 3 by 4 matrix. So there are going to be 3 rows, and it's going to be 4 long, so that's fairly long. Okay, now, to find the thing that goes in our first spot, we're going to do the first row times the first column. So we're going to have 6 times 1, or let me do a circle. So the first row times the first column. So we're going to have the 6 times the 1, 6 times 1, and add that to the 2 times 3. Add that to 2 times 3. That'll go there. So let me do our final answer as I go as well. So 6 times 1 is 6, so that's 6 plus 2 times 3 is 6. So we've got 2 6's, so there's a 12 in that position there. Okay, so we've got 12 in the first spot. Now, the second spot here is actually, will have to be a bit bigger, I think. Okay, so that's our first spot. Our second spot, because the answer's still in the top row, we've still got the top row here, so the first row of AB, but now we've moved on to the second column of B. So for this one, first row times second column, and the reason is that this point that we're doing is A1, 2. This bit here is A1, 2 that we're doing next. So we're doing the first, to find out, we do multiply the first row, row 1 of the first one, row 1, by column 2. That's the way I remember it. So first row by column 2. So this one here will be 6 times 0, 6 times 0, plus 2 times minus 2. 2 times, minus 2. Now 6 times 0 is 0, 2 times minus 2 is minus 4. Now the next point is our A1, 3. So first, the 1 for first row, so the 6, 2 row, 3 for third column. So now we've got the 6, 2 by 4, 5. So 6 times 4 goes here, 6 fours, 6 times 4, add that to 2 times 5. So 6 fours, 24, plus 10, 34. Now the last one is our A14. So A14, so we're doing the first row, fourth column. So 6 by minus 3, 2 by 1 is 2. So we've got negative 18 plus 2, negative 16. Now this next spot here is A21. So we've got the second row, first column. So now we're dealing with second row, first column. So 1, 5 times 1, 3. So 1 times 1 gives 1, plus 5 times 3 is 15. 1 plus 15. 1 plus 15 is 16. Now next, this is our A22. So it's second row, second column. So 1, 5 times 0 minus 2. 1 times 0 is 0. We've got 0 plus 5 times minus 2 is minus 10. So that one is minus 10. Next up, this is our A23. So second row, third column. Second row, third column. 1 times 4 is 4. 5 times 5 is 25. 4 plus 25 is 29. Okay, last off we've got, obviously it's going to be the second row again, and fourth column now. 1 times minus 3, and 5 times 1. Minus 3 plus 5 is plus 2. Okay, last column, well, this one's going to be A31, so third row, because 3 for the rows, and 1 for the first column here. That one there. Okay, so 3 times 1 is 3. 1 times 3 is 3, so that's 6. Next off, we've got A32, so this one, 3, 1 times this one, 0, 2. 3 times 0 is 0. 1 times minus 2 is minus 2, so that gives minus 2. Nearly done. This one is A33, so third row, third column. Whoops, third column's here. So 3 times 4, 12. 1 times 5, 5 gives 17. And last but not least, we've got A34. So 3 times minus 3 is minus 9. 1 times 1 is 1, giving us minus 8. There you go. So key things, the rows of matrix A multiplied by the columns of matrix B. Now look at your answer and look at each element. Like this was element 1, 1. So we did the row 1 of the first times column 1 of the second. Okay, that's basically how you always do them. no matter how big and ugly they look or how small and easy they look. So what I'm going to do now is check this on my CAS calculator. Then I'm going to do one more small, quick example. So at this point, if you feel like you understand, you can probably stop watching this video and have a bit of a practice yourself. But if you want to check this one on your CAS, stick with me for a moment. Okay, so here's my matrix A. Type that in. Now I'll multiply it and get up a new matrix. Now matrix B was a 2 by 4 matrix. So yes, it's a 2 by 4 matrix with the elements 1, 0, 4 minus 3, 1, 0, 4 minus 3, and then 3 minus 2, 5 and 1. And whoops, let's get that back onto the screen. There you go, there's our answer. So let's check it as we go. 12, actually let's, alright, so we've got 12 minus 4, 34, minus 16, 16, negative 10, 29, 2, 6, negative 2, 17, minus 8. So it looks like we have done that one perfectly correctly, which is excellent. Well done, us. Okay, for one more, a little bit quicker example maybe. So this one, we will do it, let's make matrix A be a 2 by 2, 1, 2, 3, 4, and matrix B can be 2 by 2 as well. It can be 0, 3, minus 1, and 1. Okay, so they're both 2 by 2 matrices. So we've got a 2 by 2 matrix by a 2 by 2 matrix. Oops, 2 by 2 matrix. So the inner product is the same, so multiplication's allowed. The outer product gives our final dimensions, which is going to be 2 by 2. So our answer is going to be a 2 by 2 matrix. So we've got, so A times B is going to be, this is our matrix A, so matrix B. Notice these are both square matrices, which is interesting. Okay, so matrix A times matrix B. Now we remember that we're going to be doing rows of A times columns of B. I'm going to write that down. Rows of A times columns of B. I'm also going to write down the answer for you. So the solution is obviously going to be a 2 by 2 matrix, so it's going to have elements A11, A12, A21, and A22. So let's answer. Okay, so the first bit here that will go in this first spot, A11, well, it's A11. So the first one is for the row 1 of matrix A, and then column 1 of matrix B. So row 1, column 1. So row 1 is 1, 2, column 1 is 0, minus 1. So we've got 1 times 0, 0, and 2 times minus 1, minus 2. So our final answer I'll put down here. So 0 take away 2 is minus 2. Alright, next spot is our A12. So that's 1 for first row and 2 for second column. So first row, second column, 1 times 3, 3, 2 times 1, 2. So that's going to be 5 there. Alright, next spot here, A21, second row, first column. So second row, 3, 4, first column, 0, minus 1. 3 times 0 is 0. 4 times minus 1 is minus 4. So that gives us minus 4 there. And last spot, A22. So first 2 for second row, and then second one for second column. Second row, second column. 3, 4 times 3, 1. 3 times 3 is 9. And 4 times 1 is 4, giving us 13. And there we go, that is our final answer. Minus 2, 5, minus 4, 13. So there we go. Best of luck with matrix multiplication. It will probably take you a little while to get used to this stuff, so I advise you to have a big bunch of practice, as much practice as you can get. Okay, see you in class.